Hi everyone, myself and Arun Kumar from SNS College of Technology in the Department of EC. In this video, I am going to share about next generation internet architectures. While internet architectures are based on OSI layers as well as the protocols, the OSI layers are the medium in which they can transfer any kind of data based on the number of layers present in the architecture. Especially for application transport and network layers, they are the essential factors for enable or accessing the data from the source. So here they are listed out how the protocols has been assigned in the various layers. First one is application layers. So in this, HTTP DNS are the main protocols because domain name system where we are mention the particular name of the website or searching the name of the particular components, so that these things are very essential for this application layer. And next one is transport layer. Whenever we can search the data from this HTTP and DNS, we have to forwarding the data conditions, so that kind of data can be transferred by transport layer protocol. So it can be transferred based on TCP and UDP model. First one is transmission control protocol, second one is user datagram protocol. In transfer control protocol, it can be used for wire connections, and UDP is used for wireless connections. Most probably in online gaming, we can use this UDP protocol. And next one, even though we are transferring the data from the application layer, it can be accessed by internet protocol IP. So this protocol has enabled the transport layer to access to the next layer, such as link layer and physical layer. So the link layer is interconnection between the two device, network layer and physical layer, because in physical layer we can able to transmit the data as a number of bits, zeros or ones. Once if you are receiving the data as a bits, then automatically just transferring the data or bytes to the next layer, that is a link layer. So the link layer is internet connection between the both layers, internet communication between the both network layer and link layers. So this is what happened in the current internet architectures. The classical view of networking. So initially, more number of nodes are connected with each subnodes. So the one of the node which is forwarding the data from neighboring node as header node. So it is the node which is used to communicate the data to the other nodes. And next one is node act as a client and server. So initially the each group one node will be act as a server, so that the server can communicate the data communication to the neighboring groups, so that all the nodes can receive the same information from the server. Once if you are receiving the same information from the servers, then automatically it can be forwarding the data to the next layer, next hop or next layer. Then it can able to transmit the information to the next layers. So like that, all the data can be shared from one hop to another hop. So most probably we can use two servers are also inside in the single hop, because the both servers are able to send the information to the neighboring nodes as well as the neighboring data. Changes in the internet. New requirements such as security, robustness, performance, and different ways of communicating in network is new networking paradigms. Content distribution. So once if you are able to transmit or forwarding the data means, then the pushing operation can be enabled. Once the hop is ready to transfer the data to the next hop means, then it can be pushed from the server, so that it can able to transmit the data or information to the next nodes. Information fusion. Even though we are able to transmit the information from one hop to another hop, the same data can able to forward all the networks which are connected in the hop, so that easily the information can be shared or retrieved from the destination. Delay tolerant. Suppose if the hop one hop is not able to deliver the data, or even if it is having some delay in the network means, then automatically the server will identify that and it can communicate the neighboring nodes. Then the neighboring nodes are activated as a delay model, so that it just it just communicate with the group itself. Then it can be checked the which node is the having more number of delay, like that it can be checked. After that it can intimate to the concerned server, so that it will able to transmit the remaining data to the networks. Implications. So reverse demand on networks. Architecture need to support all. Architecture should support future ideas. So based on architecture only, architecture and their nodes only decide that it may be able to transmit, or it cannot be transmit, like that. All the informations are based on the architectures. Next one is diverse demands. Architecture needs to host the all the informations. Network virtualization. So once if you are transferring the data from the hop to one hop to another hop, then automatically the network will be act as a virtualization model. Then it is ready to transfer, or ready to modeling the information to the next node. So it is known as dynamic installation of new networks. Programmable data plane can be added another node also. So it can be based on testbed Gen I, large configuration of experimental networks, virtualization at core Gen to allow the experimentation, a model for a potential future internet. Ongoing research on the network virtualizations are based on network node design, control panel, and new protocols. So based on the nodes assessment. So what role does AI play in managing a virtual campus on NGA, next generation internet? So it is based on bandwidth allocation based on the user. Next one is analyze to monitor the network performance and predict the failures. Next one is enable the personalized learning experience through the adaptive content delivery. Thank you.